Hi students, welcome to physics classes. Now previous classes we seen magnetic field produced by current carrying wire. Field produced by current carrying wire. Now today we'll discuss magnetic force on moving charge and current carrying wire. Magnetic force on moving charge and current carrying wire we'll discuss today. Now for example, if you place a bar magnet near TV screen, bar magnet near TV screen, not new one, old CRT TVs, like this, old TVs. Now if you place the bar magnet near old TVs, we'll get picture is distorted. Picture is distorted, not clear. Not clear. Picture is distorted, not clear. Distorted means not clear. Blur image will get. Now if you remove that magnet, we'll get screen clearly, normal. Now what happening here? What happening here? By that we can say, whenever we place the magnet near the TV screen, that field produced by the bar magnet, field produced by the bar magnet, magnetic field, is influences the motion of the electrons, or motion of the electrons are affected by magnetic field. Motion of the electrons are affected by magnetic field produced by bar magnet. That means we can say that this bar magnet, magnetic field exert a force on these charges, moving charges. Magnetic field exerts a force on moving charges. That we can see here. That force is known as magnetic force. Now once again, if you place a bar magnet near the TV screen, we'll get picture is distorted. Picture is distorted. That is because motion of the electrons are affected by magnetic field produced by bar magnet. So we can say a force acts on the moving charges. These moving charges are affected by magnetic field. So a force is acting on it, on the electrons. That force we can say magnetic force. That force we can say magnetic force. Now we can see that force here. Now these are the magnetic field. Magnetic field produced by a magnet. I already told you, into indicates field lines are going inside into the page. Field lines are going inside into the page. Now a charge Q moving perpendicular to the magnetic field. Charge Q is moving perpendicular to the magnetic field with a velocity v. With a velocity v. This magnetic field exerts a force on the charge, that is magnetic force F. Then magnetic force F equal to product of these three quantities Q, V, P. Magnetic force is equal to QVB. QVB. This is experimentally found. F equal to QVB. Q means charge, V means velocity of the charge, B means magnetic field. Now here charge is moving perpendicular to the magnetic field. Now the magnetic field is going inside, charge is going like this, horizontal, like this, arrow mark. Perpendicular, so we have taken F equal to QVB. Now if charge is moving perpendicularly, F equal to QVB. If it is not perpendicular, making some angle theta with the magnetic field. Like up or down or inside, like this, whatever it is, by making some angle with the magnetic field theta. Then F equal to QVB sin theta. F equal to QVB sin theta. Now what is the difference between these two formulas? When it is perpendicular, when field and charge are perpendicular, we can use this formula. This is generalized formula. F equal to QVB is generalized formula. When it is perpendicular, theta equal to 90 degrees. Then sin theta equal to sin 90. Sin 90 value 1. So F equal to QVB. Now if it is parallel, charge and magnetic field parallel to each other. What is the magnetic force on the charge moving parallel to the magnetic field? Very, very important question. What is the force acting on the charge which is moving parallel to the magnetic field? Parallel means 0 degrees. So sin 0 equal to 0. Product of this, then force becomes 0. Product of QVB with 0 becomes 0. So whenever magnetic field and charge parallel to each other, there is no magnetic force. 0. How much it is? Magnetic force is 0. When it is perpendicular, maximum, it is the maximum force acting on it. Okay. Now force is acting. Now here we know charge direction, Q, charge direction, and magnetic field direction, field direction, electric charge direction, electric current, and field direction we know. Then what is the direction of force? What is the direction of force? To find the direction of force, we can use right hand rule. Right hand rule. Right hand rule means three fingers we should place perpendicular to each other. Three fingers, thumb, forefinger, and middle finger. Each one we should place perpendicular to each other. Now here forefinger indicates direction of current. Forefinger indicates direction of current, and middle finger indicates direction of magnetic field. Direction of magnetic field. Now thumb indicates magnetic force. Thumb indicates magnetic force. Once again, forefinger indicates direction of current, charge, direction of current. Now middle finger indicates direction of magnetic field. Direction of magnetic field. Now thumb indicates force, magnetic force. Now here we will find what is the direction of force. What is the direction of force? Now see, direction of current, forefinger, magnetic field into the page, magnetic field into the page. Now thumb is pointing upwards. Means like this, force is acting on it. Upward force is acting on it. Okay? Yes. Now a current carrying wire is placed in magnetic field. Current carrying wire is placed in magnetic field. Now the current is going like this. This is the magnetic field. Going into the page. Current is upward direction, arrow mark. Magnetic field into the page. Now the length of magnetic field is L. Now charge when going into the magnetic field from here to here, it experiences a force, magnetic force. Now the time taken from here to here we can take t. If a charge enters into the magnetic field and leaves from the magnetic field, time taken is t. Now the force is acting. Let us take that force F equal to, we have formula QVB. F naught we will take QVB. Now here QV means this length traveled by the charge in a time t. Length by time. L by t into B. Now can we write Q by T into LB divided by T? For anything we can write. So Q by T is electric current, ILB. F equal to ILB. Force acting on it is ILB if it is perpendicular. If it is not perpendicular, F equal to ILB sin theta. ILB sin theta. Now this much force is acting on the wire. Now due to that force, wire will be shifted from strong magnetic field to weak magnetic field. From strong magnetic field to weak magnetic field. Now here already we seen current is flowing like this. Magnetic field is inside acting. inside acting. Now the force is acting left side. Force is acting left side. Current is acting upward. Arrow mark. Current is acting upward. Magnetic field is into the page. Now force is acting left side. So due to that, this wire shifted from strong magnetic field to weak magnetic field. Like this, it will be shifted. It will be shifted. A force acts on it. It will pushes out. It will pushes out. Okay. This is a, by using this, we have invention of motor. Current carrying wire placed in a magnetic field experiences a force. Current carrying wire placed in a magnetic field experience a force. That we'll discuss in next class. Thank you for watching. Please subscribe.